Hi everybody, Peter from Global Roofing Solutions. We were involved basically from the start of Andrew and them from being in architects. We started this project in May 2017 and yeah, I think one of the biggest curveballs that we had was the curve on the building with your cranking that we did on it, and then also the natural sprung side of the building.
Andrew, do you want to introduce yourself and tell us what your role is?
My name's Andrew Pritchard, and I was the architect on this project for the CDC and Hello Automotive.
Okay, Alexander, is it? Can you tell us what your involvement in the project was?
Yes, my name is Alexander Semple. We were appointed as the structural and civil engineers on this project. And yeah, that's right, that's me.
Short and sweet. Dion,
Yep.
can you tell us what your role in the project was?
Okay, so it's actually not Dion, it's Donovan. Dion's on his way, he's stuck in traffic, but I was actually the contracts director on the project from WBHO. Our involvement was taking the difficult design that Alex and Andrew put together, and we had to build it. So yeah, very interesting, but awesome idea.
Can we maybe just start with what the architectural brief was for this project, Andrew?
In very simple terms, it's the client was Hello Automotive, who are a international automotive supplier. Their wish was for a building that would be synonymous with sort of their spirit of innovation and the forward-thinking nature of them as a company, promoting the brand. And as such, they were looking for something slightly different. In other words, not just a closed box. And that was essentially, I think, where the concepts essentially came from the client, and naturally from the CDC as a development zone. There was obviously the promotion of that development zone for CDC. In terms of the overall form of the building, you see that the offices are obviously all at the front, which is all quite visible from the freeway. So there is there's a public element to the structure, and the glazed front essentially has a transparency to it, which I guess translates into an honesty, transparency of a business. Naturally, the warehouse component is all enclosed and needed to be secure. The building itself obviously needed to also have an element of flexibility to it, in that should that tenant leave, you needed to be able to have a building that could be used by another tenant quite easily. So in many aspects, the space is provided.
How would you say that steel was really integral to achieving the architectural brief for the structure?
I think Alex might want to come in on this, but from my perspective, to create the spans required, steel seems to be the natural material. Your cost per span is best in steel. Trying to have done similar structure in timber or concrete would have been extremely costly, complex. So the steel structure is very suitable for what we were trying to achieve. I don't know if Alex maybe has anything to add to that. I think from Peter's side, sorry, he might want to add also the seamlessness of that roof, where you essentially have the concealed fixing, so you have no perforations. Obviously, your water tightness elements are better. Yeah, I don't know if Alex, you have anything to add?
No, I can comment on the functionality of steel is, as Andrew said, on the spans, it's very functional. The the structural ability of steel is far outweighs any of the other going materials. But one of the main one of the nicest things of the structure is that the exposed steel is it's visually appealing, and it's impressive, and as well as it's functional. So it's got all over advantage of being functional as well as aesthetically pleasing, and because of the shape. It's not your standard portal, industrial type. Even though it's built in an industrial zone, it doesn't feel like an typical industrial building. So, and the steel theme went through right into the offices as well, where you'll see steel columns, exposed, where aluminum shop fronts are attached to, and they're all part of the visual impact on the structure. So they were dual function structurally as well as aesthetics. So we think it was all over a good use of materials, and to get an architectural look that was acceptable to the client, as well as coming in with the costs with almost in the normal rates. Okay, thank you.
Emmanuel, any questions or comments from your side so far?
Yes, a question for Alex. So what is the lateral system of this building? Is it like a two-pin arch, or in both directions? How does it work?
No, it's fixed in the one direction. You'll see we had quite a substantial base, which was also an architectural feature on the one side, and then pinned on top of a concrete column on the opposite side. We did have some problems with the horizontal deflections. Not problems, but the horizontal deflections on the pin was quite excessive. So we actually semi-fixed it on top of that concrete column, and then obviously designed the concrete column to take the moments down into the base. So on the left-hand side, that base at the bottom is a fixed moment connection. The one on the other side is a semi-fixed on top of the column, and the columns is a moment column. The moments are transferred down to the base. You'll see the column. It's actually quite a substantial. It's about, I think it was a 700 or 750 deep column. It was in the initial design. It was I think a 300 by 300 column. And obviously with the detailed design, we had to ask the architect to make it wider. And that's where you'll see the concrete columns actually got a slight slope, also adding to the aesthetics of the building.
Great. So we have touched a little bit on the structural framing. What were some of the challenges that you had with the structure in the design phase, and then maybe in the fabrication and erection, and perhaps even cladding, Peter, if you want to chime in here? What were some of the challenges that you had, and how did you overcome those challenges? Alex, do you maybe want to start first?
Okay. Firstly, as you can see, it's not your conventional type of building. The curves, it was made up of there was 4 different radiuses on that curves to be able to achieve the shape that the architect wanted. Fortunately, with good design packages, the design is pretty much easily loaded into a design program, which we spoke on, that we used. So the actual analysis and the design of the structure, even though it looked very complicated, it's based on your standard truss principles and framing principles. So to obtain the sizes and was relatively standard. However, because of the tubes, we were concerned that, with this, especially on the one side, that the radiuses were quite tight, and we were worried that with bending tubes that they will flatten out and become like egg shapes. So we actually did have some samples done before we did the actual construction, and we had to increase some of the wall thicknesses on some of the tubes to minimize the flattening of the shape. So by increasing the wall thickness from, I think it was a 3.5 to a 6, that was then achieved, and it worked out quite well. I think the actual manufacturing of this was actually a bit more of a challenge. Fortunately, we had a very good subcontractor with WA appointed. We had the right technology to model the structure in their manufacturing processes. I think they use a Tekla package to do it. If it wasn't for them, it could have been a different scenario on site.
Mm-hmm. So then, in terms of the actual the erection of the structure, who would be best placed to answer those questions?
I think Donovan probably.
Yeah, Donovan, do you just want to give us a little bit more detail on the actual erection process?
Sure, no problem. Well, the erection, like Alex says, I mean, the structure itself was quite unique. I think the contractor that actually did it, USS, did a phenomenal job in actually getting all the curves right, or the whole the rolling right. I think that was the most difficult. We had a couple of challenges as well in, I think, Alex and design nice bases. I think we had like little spaceship bases at the bottom that we actually got precast molds with holding down bolts inside, that we actually got them in the right position, that all the concrete work at the base was actually, it was accurate. So that when they came from their design, and even the columns on the other side were all up to a certain section, it was straight, and then it all, not tapered, yeah, tapered. They're all tapered to a degree. And so the whole thing, the accuracy in the concrete was done very well. That when the guys got to site, the actual formation of the structural steel actually fitted on very nicely. So the structural steel went on. The purlins weren't an issue, obviously. Purlins are quite straight. But I found the part, and I think Peter actually raised it earlier, to get the cranks of the roof sheet. To me, I mean, that was the finishing product that you actually see at the end. I think your photo that you showed was a stunning photo from a distance to get that curvature right. And each and every crank, I mean, we did a couple of samples to get the cranks right, to get to get the curve right. And each and every crank on the whole sheets, on the sheets, actually all lined up. I mean, if you had one sheet crank here and the other one there, wouldn't have been seamless. So I think the cranking, I think the guys from GRS with the contractor, there was a lot of time spent in getting the first, not mold, but getting the first template done. From the first one they did, they did a lot of measurements, and everything was taken from the first one. And from there, they got it all seamless. And I think it actually ran smoothly after the first one. I think the first one took a bit of time, but after that, there was actually a very simple process. So the setup took time, and which we spent a lot of time and money on getting the setup right. But then it was quick after that. And then it wasn't as simple as just erecting, because you couldn't slide it up because it wasn't a straight sheet. You had to get a crane on the one side, a crane on the other side, scaffolds at the right angle so the guys could stand on, because the guys also couldn't stand on a normal roof sheet. You had to get scaffolds set up properly. So it took a bit of time to get that done, and getting the guys access onto the sheeting. But I think those are the most challenging. So yeah, the structural steel was a phenomenal innovation, but once they got the rolling done, I think it was a little bit easier for them to get the rolling done right. I think the sheeting was probably the most difficult from our side, to get it erected and get it put up.
Good. Peter, do you want to jump in here and tell us a little bit about the cladding on this project?
Yeah, thanks Donovan for that. Yeah, as he said, the most important was to get the cranks lined up properly. What we did is we did fly down Jagru, he's our national quality manager, and he actually assisted us in it. If we take in consideration, it is 41.38 meters long, one sheet. So over the first 10.8 meters that we've got 43 cranks in there. The second 6.5 meters, we've got eight cranks in there, and then the rest of the 24 meters is actually naturally sprung to the back of the building. So yeah, to get 330 sheets to line up exactly with the cranks was a big challenge for, I think, all of us. Yeah, once the guys got the first 2 or 3 templates right, it went well from there. I also have to say that in the cranking process, we did do the cranking on site. It was a mobile cranking mill that went there. The approved contractor, Skeltimer, that actually installed it, they had to build scaffoldings right next to the cranking mill, because as the sheet goes out, it actually gets higher and higher and higher. And I think we ended up with 15 or 20 meter scaffoldings next to the cranking mill to catch the sheet. And then, as Donovan said, the second one was actually getting the sheets on top of the roof without scratching the other ones, because it is a darker sheet. It's African charcoal, they call it. So that the scratches you pick up very, very quickly.
And just remind me again what the profile is, Peter?
It's a clip lock. We use the clip lock 406 for a couple of reasons. The two biggest reasons is it's a smaller profile, so it's not as wide as your normal clip lock 700 or your clip plug that we do. So the sheet per kg is a little bit lighter for the guys to handle, to move it up to the roof, and then also it springs easier than what your clip type would, because that's your more rigid concealed fixing system that you've got with GRS. But the clip lock, yeah, it allowed us to actually naturally spring the last 24 meters.
Good. Emmanuel, any questions or comments?
Yes, one for Peter and one for Donovan. Peter, how does the curved roof react to expansion, like as in thermal expansion?
Thermal expansion was actually exactly the same as what a flat roof would, because it's not pierced at all. I think we put some gutter bolts in where the gutter is where your natural sprung is, but because it's a concealed fix system, it still allows the sheet for the movement up and down to breathe easily, if I can say that.
So it doesn't pop out when it's
no.
No, okay.
No, it still allows itself to expand and extract.
All right. So a question for Donovan: considering how complicated this project is, Andrew has definitely given a challenge to everyone here. Did you have to pre-select contractors during design, or did you follow a standard design bid build, and somehow this worked out?
No, in terms of the roof sheeting, I think we've got very good roof sheeters, which I think Peter works very closely with. So Sheltermer was one of them, and they are a very good contractor, but I think the biggest role player was GRS themselves in getting the quality control, like the right guys down to assist with the cranking. You know, like our contractors, they just put everything I mean, we just lifted it and placed it in position, but the actual milling and the cranking was the vital part in getting that right. So the guys that actually did that were, I mean, to me, they were the major role players in getting the profile right. The contractors, I mean, we could have used, we got very good contractors here in roofing, and any one of them could have been able to do that. In terms of the structural steel, I do believe that was a specialized item, and I think the right contractor was chosen for that. I don't think, and Alex will probably be able to come in here, I don't think many others would have been able to do that project. I think we definitely selected the right structural steel contractor for that project.
So was that a pre-selection, or meaning during design, or was it post?
Correct. Yes, they were. Yes, but the roof sheeting, that was pretty much based on tender. We got, like I said, either one of them could have been able to do that, the roof sheeting.
Sure.
But the structural steel, definitely not.
Interesting. Yeah, well done. It looks very nice.
Thank you.
Thank you.
Great. So how, maybe I can start with Peter and then we'll move on to Alex and to Donovan. How would you say that this project specifically demonstrates the benefit of steel as a material?
To be honest, I don't think there's any other material out there that will be able to handle that type of curvature and actually still stay in place. Yeah, I don't know what else to say, but yeah, if you think of any other building material out there, steel you can manipulate to actually form what you want on a building.
Good. Alex, okay, wait, Andrew.
Sorry, Denise. Peter, I agree with you to a degree. You can manipulate it, but I mean, the accuracy was difficult. I'm saying there was a lot of care and effort put into to get it right. It wasn't a matter of just, you can manipulate it. I mean, like I said, the amount of measurements that went in to get the cranking right, I think there was a lot of pre-planning done and a lot of, to get the first sheet right to actually make the rest of it a success.
Good. Andrew, did you want to add something there?
I was just going to say, with steel, I appreciate the difficulties as Donovan's referring to, but steel does allow for a certain level of precision, which not all materials would have given us. And it's specifically that precision that you see in the finished product, where the cranks are perfectly aligned. Each truss is identical. And I think that does help in the overall aesthetic and finish of that project.
Good. Alexander, is there something that you'd like to add?
Well, not really. I mean, once the project landed on our desk, I mean, the first thing we didn't even consider any other materials. So steel is the natural selection. It's the most structurally, it's available. It's practical, and you can like do fancy shapes like this. It's very versatile and it's cost effective as well. Just for interest, this structure actually started as a 3-dimensional truss, and it was to try and save money and costs. It became a two-dimensional truss. We still gave the same architectural look as a three-dimensional truss would have done, which was the original intent, to have like a space frame type of look to it. And changing it to a two-dimensional truss, the costs came down with less materials. The sizing didn't change drastically, so it's very versatile.
Good. Emmanuel, any comments from you before I ask my closing questions?
No, it's just a very nice project. I'd like to compliment the whole team, Andrew for his vision, and of course the rest of the team for actually being able to implement it in such, at least the pictures look very nice. This would have been a very nice project to go visit. It's too bad we didn't go to visit.
More than welcome to. It's still
there. We'll make the plan. Peter, what would you say you're most proud of on this project?
They're definitely how the GRS team came together with the professional team from basically our drawings office that actually did the drawings for us. I think we did 3 or 4 renderings on that on different types of concealed fixed systems. But thing that I'm most proud of is how it looks. Everything lines up perfectly on that job. Minimal to nothing was scratched, dent. It came together very nicely with the whole team.
Andrew, what are you most proud of?
Besides being a unique and exceptionally interesting looking building, which I think reflects both the client's aspirations and hopefully a benefit to the general public in terms of the built environment. I think one of the things that stood out on this project was specifically the teamwork. After 30 years of doing buildings, this can well be one of the best teams that came together. We had exceptional contractor, the coordination between Peter, his team, Donovan, WBHO, the engineers, Alex. It actually stood out as an unusual, when I say unusual, teams normally work together. But this team particularly gelled where I think everyone had a simple, united vision, which translated into a very successful project. So yeah, we'll go into the team.
Good. Donovan, is there anything that you'd like to say in closing? What you think really went well in this project?
Yeah, I think the project from the beginning went well. Like Andrew said, I mean, the team were committed. I think it was also run very well from the project management side in terms of cohesion. But it was very good. But the biggest thing for us was obviously finishing on time and the quality. I think the quality is I've been in a lot of projects. It was a really nice, and it was well delivered. But also just the uniqueness. I mean, it sits on the freeway, like they said, on our N2. And everybody that actually drives past, I stood out, and everybody was saying, whenever they drive past, they always said, "Are you building that building? Are you building that building?" So, it was a unique building that actually we were very proud of. I mean, it was something different. I haven't done something to that degree in terms of all the cranks and all that. So it all came together, and just being part of a unique project was phenomenal for us.
Good. Alex, anything in closing?
Yes, just a final. Andrew said most of what I was going to say about the teamwork and how we all work together. It was a fantastic experience working with everyone, from contractors to consultants to clients. It was really a pleasure to be on that job. the visual aspect of this building, like everyone is seeing, you can see architecturally it's a phenomenal looking building. And you can also see the structural from our side. You know, you like to see the structural parts being a serving function of being, you know, keeping the building up, but also looking great. You know, our office is very proud of this project. We've, you know, in PE, there's very few buildings of this nature that actually get built. A lot of the times they get canned because of costs, or, you know, they're just over the top for this region. So we are very proud of this building.